Okay, good morning. You're on to the mathematics multiverse, and today we'll be going into the realms of further mathematics. I'll be looking at pure mathematics. We had said earlier that further mathematics is broken down in this system into three realms: pure maths, vectors and mechanics, and then statistics and probability. We'll be exploring pure mathematics in the matter of binary operations. We've started this series. We remember we said that the concept of binary operation is to check out the rules of combination for two elements in a non-empty set. We try to check out the relationship of two elements in a non-empty set. That gives us a bit of a summary of that. And today we'll be going into the different aspects of binary operation. To understand binary operation, we'll be looking at binary operations from the matter of properties. There are certain properties that enable us to understand the matter of binary operation. So we'll go straight ahead to look at them. I'll try to list some of them. I'll do a mental listing of them. And then afterwards, we'll now try to delve into them one after the other. So we'll look at properties. Properties of a binary operation. Or of binary operations. Let's make them plural. The properties are essentially tests we carry out to see how some of these behaviors are obtained. Number one is a matter of what is called closure property. Closure property. Number two is what is called commutativity. Commutative property. Number three is what they call associativity or associative property. Number four is what is called distributive property. Distributive. And number five is what is called the, we call that identity element. Identity element. And finally, we have the one we call the inverse element. So I just use the word inverse element or inverse. Sometimes you could do inverse property or the identity property. Now, these essentially are the 6 properties. Now, what I try to do is to try to tax myself from memory to also tell you that some of these things we do are things you can retain. And in teaching, I will try to do a mix that's between being technical and a little light, because my observation over the years on these topics that students seem to see this topic as one very abstract topic. So I may not go in depth to begin to use all those funny symbols and whatever, but I'll try as much as I can to bring it to your level. And maybe in the future, I'll do more technical videos on this. But for now, I just want to ensure that that fear barrier is broken and you can relate with these properties. Okay, so we've listed them on the board, 6 properties we'll be looking at. The first property we want to talk about is that borders around closure property. So what does closure property talk about? Remember we said that binary operation works under the context that we are dealing with a non-empty set. Please don't forget this. And if you've studied set, you understand what a non-empty set means. That that set must have at least one element. If that set has no element or member, we can't consider that as a set. If you recall from my previous video, I did say something also. I said that we'll be looking at the properties and numbers. Remember we talked about numbers, and we said that numbers have different types, and I tried to list them the other day. types of numbers, because these are the things that will improve your understanding of the topic. We said number one, we have what is called natural numbers. Number two, we have what is called integers. Number three, we have what is called rational numbers. Number four, we have what is called irrational numbers. And number five, we have what is called complex numbers. And all of these, first four, come under what is called real numbers. Real numbers. So you discover that this is a very big category. Now, the set or the set of numbers given to you, or the definition of that set will determine the groups of numbers you will find. Usually for the real numbers, you usually will see the letter R. Letter R will suggest that it's a group of what? Real numbers. Technically speaking, any letter can be used. Any letter can be used. If you have your background knowledge on sets, it will help you understand this topic better. So I want you to also go up to my channel and read and watch videos on sets, because you need set knowledge and numbers to be able to flow with some of these ideas. So if that is said, usually integers will usually be represented by, I think this is N and this is Z. So I wouldn't bother going into a lot of their letters represented, because sometimes the narration is dependent on the author or the established text, the established idea they want to achieve. But in keeping it very simple, when you see arrow, it means real numbers. It means the possibilities are endless. You have, in fact, real numbers will suggest all numbers that are real, that is natural numbers, integers, rational numbers, and irrational numbers. As I begin to solve, because one of the things I'm going to do in this exercise is this, I'm going to try to solve almost all the questions, and I'll try to avoid solving examples, except the need really is. I may have to avoid solving examples. And for virtually all the schools here in Nigeria, the text we use is this one they call New Further Maths Project. It's about the text we use. This is, I think, the most recent edition of it. This is the text we use for these course. It's called the expertly revised and extended version. So this is what we use for this particular course here in Nigeria, further mathematics. And it helps. It helps. And one of the counsel I've always given to my further math students is this: when you are handling further maths, don't leave any question behind. If you pick a chapter, run through all your examples and run through all the questions. That's the secret of further maths. Don't say, oh, I know the idea and I understand the topic now and I want to move to something else. No, go through every topic, go through every exercise, go through every example. That will enhance your understanding. So with that said, let's go into the work proper.